Hello and welcome. Possibly this is our third lecture on atomic structure. Am I correct?
Again, sir.
Yes, sir.
Yes. And in this third lecture, I am really convinced that I can take you to the end of Heisenberg uncertainty principle and even talk something about Schrodinger's wave equation. So before that, let me just talk something about Bohr's theory, which you might have recorded in your copies from my file. That the Ritz equation, that is a very, very handy equation to calculate on hydrogen spectrum or any other hydrogen-like species spectrum, that you can just write down. We shall be, going in a fast rate, I mean, with a good pace. And this is supposing E of a lower cell, that is minus k z square by n1 square, and n2 is any higher cell minus k z square by n2 square. And if you take the difference, which is required to know what is the frequency or wavelength or wave number of the Rasagulla, that has to be absorbed or emitted during absorption mode or emission mode respectively. So del E is equal to E n2 higher minus E n1 is equal to, if you take this will be plus. I'm just leaving steps. This minus minus will be plus. If you take k and z square common, then it will be 1 by n1 square minus 1 by n2 square. This minus will remain, but this minus will become plus. And in place of del nu that we have studied in the one of the postulates of Bohr's model, that is equal to hc by lambda, or simply hc nu bar is equal to kz square by 1 by n1 square minus 1 by n2 square. What is nu bar, Shruti? Shruti, what is nu bar? श्रुति
Yes, sir.
कौन सेटा न्यू बारटा कौन
Wave number.
यस
Wave.
हाँ सेमती सिना इंटरेक्शन कले गोटे शिक्षक को भल लगे ताको पढ़िबा को इच्छा हबो यस वेव नंबर व्हिच इज रेसिप्रोकल ऑफ वेवलेंथ and its unit is not angstrom inverse, it is centimeter inverse or meter inverse. Angstrom, nanometer, micrometer, they are all ornamental units to represent very small measurements. So if you keep a nu bar here on the left side and bring hc to the other side, then that comes a new constant called the Rydberg constant, r z square 1 by n1 square minus 1 by n2 square. So this is called Ritz equation, and this r is called the Rydberg constant, Rydberg, which is nothing but k by hc. And if you substitute the value of k by hc, it will be 109,677 centimeter inverse. Or if you make it meter inverse, then you will get 1.09677 into 1, 2, 3, 4, 5. So you must be acquainted both with yes, 7. 109,677 1.09 hele 10 to the 7 meter inverse. So this is given in the question. Otherwise, you remember. Some little different values are given in different text questions. Maybe some will give 700 or something, but 109 will be always there. But this might change. Doesn't matter if it's not given, then 109,677 centimeter inverse or 1.09 into 10 to the 7 meter inverse. You'll do. So, and if you take del E as h nu, not h c nu bar, is sorry is k z square into 1 by n1 square minus 1 by n2 square, and find a nu directly, then you have the constant k by h. Z square. So this constant is 3.29 into 10 to the power 15 second inverse. So the constant has no name but 3.29 into 10 to the 15. So if you are new, new bar likh dile, I'm so sorry. So if in some question you are asked directly to find a nu of some hydrogen jumping emission ho ya absorption ho. So you can directly use this equation with 3.29 10 to the 15 as the constant k by h to find the value. And in fact, this value was empirically means determined with experiment. In the Balmer series, they found this constant while matching to their first line, second line, third line, fourth line, at least 4 lines are visible. As I told you, in each hydrogen spectrum, what happens to the lines which converge, come closer and closer, and after a few lines, they overlap with each other to form a continuum. And say, I'm giving you a question. Supposing Li 2 plus spectrum ray, what will be the lambda for a third line to first cell transition? Hence, so far you are using the K method. K, you can just forget about using the K method, directly use lambda. Once you find nu bar is equal to R, R means 109,677. Let us do it in CGS. Z square is how much? 3 square, because we are not dealing with hydrogen. In hydrogen, Z square is equal to 1. But remember, this is not a hydrogen spectrum. This is a hydrogen-like species, and that too lithium 2 plus spectrum. So to which Bohr's theory is applicable. And well, into it is the lower cell n1 is always n1. 1 square minus 1 by 3 square. So you can calculate what is the value, 109,677 into 9 into 8 by 9. So I think 9 get cancelled, and whatever comes, कितना asla? This is centimeter inverse.
Sir, 877,416.
Huh?
877,416.
And lambda is equal to reciprocal of wave number. So 1 by 109,677 into 8. This is centimeter. The inverse of centimeter inverse is centimeter. And immediately we convert it to angstrom, because angstrom is an ornamental unit. So if you convert into angstrom, that becomes 10 to the power 8 into 109,677 into 8. So we can here, this is angstrom. We can make a little 1.09, then forget about 677, or take at least this one into 8 into 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 angstrom. So if you simplify, take 10 by oh, 10 to the power 5 into 10 to the power 7. So what is the answer? 10 divided by 8.77. Is it the multiplication correct?
Sir, 877406.
8 point?
77406. Sir, ଗୋଟେ 7 ଛାଡି ଦେଇଛନ୍ତି ଉପରେ।
ହଁ ମୁଁ ଛାଡ଼ିଛି ଜାଣିକିରି ତିନିଟା ସିଗ୍ନିଫିକାଣ୍ଟ ଡିଜିଟ୍ ନେଲି। ତ ଏଇଟା କେତେ ହେଉଛି 10 ବାଇ କେତେ ଆସୁଛି? A calculator, you must always carry a calculator and immediately mute your voice. Once you talk, open your unmute and then mute. Otherwise, there will be a very disturbing sound, and that will affect the quality of recording. Because I'm making all my videos public. At least a few guys will definitely benefit out of the discussion. And so এটা কেতে আসলা? Mr. Mohanty.
Sir, 113 point.
113.97 sir, 113.97
Yes, sir. 130.97.
97
Yes, sir.
Yes, sir.
into 10 to the power 2. So that becomes 113.97 angstrom. Tell me in which region that Rasagulla will fall? 113.9.
Sir, X-ray.
X-ray. So this photon, X-rays is always a plural. So this single photon, this is a single photon, will fall in the X-ray region. You can't see. Of course, you can take the spectrum, but you can't see it in a screen. Why? Because the nucleus has additional 2 protons and many more neutrons. So the attractive force, the attraction of that 3 protons and 4 neutrons to the electron, single electron, will be more. Therefore, the same first cell, K cell, the radius will be less in case of Li3 plus compared to hydrogen. And also, we found out what is the wavelength. Wavelength in case of 3 to 1, which is Lyman series of hydrogen spectrum, will be in the ultraviolet region. The first one is 1216 angstrom that you got. I gave you a homework question. What will be the second line? Have you done that?
Sir,
Yes,
second
sir.
line of line.
କେତେରେ ଆସିଲା? ମୁଁ କହିଥିଲି ତମକୁ ଯେତେବେଳେ ପଢ଼ଉଥିଲି, ମୋର ମନେ ଅଛି 2 to 1 କଲେ ଆମେ 1215 ଆସିଥିଲା, 516. And then I gave you a task 3 to 1 କରିକି ମତେ କହିବ, କରିଛ କି?
ଆଜ୍ଞା sir.
କେତେ ଆସିଲା?
Yes, sir.
sir 1026
Yes,
sir 1026
1025 or something like that, 1000 something. Chinmay, କରିଛ? Chinmay, are you there with us, or you are sleeping?
No, sir.
Hmm. And that was in the UV region because it was hydrogen spectrum. But same 3 to 1. And the third line, which is from 2 to 1, 3 to 1. Yes, this is corresponding to the second line. 3 to 1. Yes. 2 to 1, 3 to 1. This is the second line of hydrogen spectrum will be falling in 1025 angstrom, which is in the UV region, because UV region starts from 150, right? Am I correct?
Yes,
Agya.
sir.
To 3800 angstrom. So, but this is in the X-ray region. Why? Because less the lambda, more is the energy. So the energy requirement for jumping from 1 to third, that will be same as jumping from 3 to 1 back. So because of the greater attraction, more energy will be required for any jumping 1 to 2 or 1 to 3 or 2 to 3 more. So corresponding wavelength will be less. Hydrogen say He plus spectrum, lambda will be less. Maybe आमे जदि calculate करिबा helium plus रो एटा सेम थी पढ़ी पारे कोठी सेटा पढ़िथिला 1000 समथिंग रे एटा हुए तो पढ़ी पारे मोड देउची टास्क homework second line of Lyman series of, but this Lyman word is used for hydrogen spectrum. I'm just second line of in the He plus spectrum corresponding to second line of hydrogen spectrum. So that means second line means first line is 2 to 1. And I'm saying corresponding to Lyman spectrum means the destination cell is first. If it is emission spectrum. Or if it's absorption spectrum, then the source will be 1. 1 will be always involved in the Lyman series. So second line will be from 3 to 1. What you do, you can use the Ridge equation once again. Nu bar is equal to 2. This will be 109677 square because we are dealing with helium spectrum, and 1 by same 1 square minus 1 by 3 square. Calculate lambda, which is 1 by lambda, nu bar, and convert it to angstrom. What is the value, and see in which region does it belong. I suspect it will fall same in the UV region, because for Li2 plus spectrum, the same second line is coming close to the UV. It is 118 or something that we got, 130. 150 is the last. So I think it will be much less than hydrogen. 1025 to बहुत कम होगा, but it will be more than 113.97. Maybe it will fall in the the first part of the UV spectrum. Well, if you are really passionate while you are sitting with me, I think by now you would have answered. There is a guy in your 12th class batch. He's so passionate about learning that when I say like this, home task, and I spent some time in telling some, maybe gossiping sometimes. He answers and tell me, I think. So if you are good at calculation, then we can use the time and answer. ତମେ କିନ୍ତୁ ବସୁଛ, ମତେ ଲାଗୁଛି ବସୁଛ, ମୁଁ କହିଲେ ଏ କରିବ। नो वेल, ମୁଁ ଯଦି ଡାଇରେକ୍ଟଲି ପଚାରିବି ହ୍ୱାଟ ଇଜ ଦ ଫ୍ରିକ୍ୱେନ୍ସି, ମୁଁ କହୁଛି, ଆଉ ଗୋଟେ କ୍ୱେଶ୍ଚିନ୍ ଦଉଛି, find the frequency directly of the photon to be observed. I'm not giving a spectral problem, but the reverse problem. Yeah, absorption spectrum, for example, observed when electron in, say, hydrogen jumps from 2 to 5. Now, can you tell me what is the line number of which hydrogen spectrum if it comes in the emission mode? Which series, which line? When electron from the fifth cell jumps back to the second cell, it corresponds to which line of which series of hydrogen spectrum?
Sir, Balmer third line.
ଆଜ୍ଞା ସାର୍। ସାର୍ ବାଲମର ଥାର୍ଡ ଲାଇନ୍।
Precisely.
ସାର୍ ବାଲମର spectrum।
Yes, precisely, both of you are correct. Because if it is 2, then it is Balmer. And 3 to 2, it is first line. Then 4 to 2, it is second line. And then 5 to 2, it will be third line. So this will be the first line here in the orange region we calculated. Second line will be having, second line 4000 something asthimo. Third line is same 4200 something. This A line. And tapare to lodalodi aramb hoijibo. This lodalodi portion is called continuum. Continuum, this part. Although the spectrum as a whole is discontinuous, is a line spectrum, but the last part where overlapping happens, that small little portion which is not distinguishable, the lines, they merge with one another, they overlap with one another, that small little patch is called the continuum of any series. So in this case, you can find, instead of finding nu bar and correlating with nu, you can, if you remember the value, nu is equal to 3.29 into 10 to the power 15 second inverse to 1 by, if it is 2 square minus 1 by 5 square, then you find directly in Hertz. You understand?
Yes, sir. Sir, 6.909 10 to the power 14.
13.
6.909 into 10 to the power 14.
Yeah.
Sir, 909.
6.909
10 to the power 14.
Okay. Then we talk about ionization energy. Now, that the definition part you forget. That will be done in periodic classification program. But let me tell you that it is the amount of energy needed to remove the electron, to pluck out electron from its ground state, the K cell, to infinite distance, so that it will not come back again, and so that hydrogen will be converted to hydrogen ion. You can either write minus E here or plus E here. So all in the gaseous state. That is the definition. And of course, for hydrogen atom, since the energy of the electron in the first cell or in the ground state is equal to, who can tell me in electron volt? What is the energy of the electron in hydrogen atom in electron volt? अरे कहो ना.
Sir, minus
minus
13.6
13.6.
EB.
Yes. I am primarily making, having the class for you. But that means we will not waste our time, because we are having limited time and I am making the video for public. So we'll not waste our time, but not sacrifice our interaction. I'm telling in English because I want you to listen to English continuously. Sometimes I'm breaking down to Odia, because unless I do that in the beginning, you will feel unfamiliar and you may be alienated from the program. That is why sometimes I break down. And after some days, there will be no necessity of coming down to Odia. Of course, I love, because you are the guys who were from the Odia medium. And we work for the Odia medium schools. That doesn't mean that we will continue to speak in Odia in classes and not train our students to talk in English, listen in English. We have to do that, because in the world of competition and in globalization, you always have an edge, not mere edge, a distinct edge of edge over others if you communicate in English. And E1 is minus 13.6 electron volt. That is, in general, it is K. Or it is 2.18 into 10 to the minus 10 to the minus 18 joules for atom. Now, if we give plus K amount of energy, so ionization energy, as we will write as IE, is equal to plus K. If plus K amount of energy is supplied or the electron absorbs at the ground state, then it will go to the infinite distance. As much it has lost while coming from infinite distance to the first cell, same it will lose. So in terms of K, it will be plus K for hydrogen atom. And for helium plus, we will find IE2, because helium plus has only one electron. One electron has been already knocked out. That is called the first ionization energy, which will be determined by different experiment. We will talk about that in our periodic classification program, how to determine IE1, IE2. And from Bohr's theory, we can find out what will be the second. This is the second ionization energy of helium atom. But ionization energy for helium plus, if it is already helium plus, it has only one electron, so you will say ionization energy of helium plus. But for helium atom, it is the second IE. Who can tell me? Because here the actual term is E is equal to minus K Z square by N square. N is 1, because it is to be ground state to find out the ionization energy. From the ground state, it will go to infinite distance. So, we କେତେ ହବ କିଏ କହିପାରିବ?
Sir, 54.4.
Obviously, it will be minus 4K, because Z for helium plus or helium inside the nucleus is 2 square, 4 minus 4K. So the energy, 4 times more energy will be required to remove the only electron present in He plus to the infinite distance, so that it will become, He plus will become, He double plus, all in the gaseous state. So this conversion, He plus to He double plus, that is plus 4K. So IE2 is equal to plus 4K, and that is In electron volt, it will be 13.6 electron volt into 4, whatever it comes. And for Li double plus, the IE3 we can measure. The first electron, second electron, IE1 and IE2 are determined in a different experiment. We'll not talk about that. But Bohr's theory is applicable to determine the conversion of Li2 plus to Li3 plus. That is called the ionization energy of Li2 plus, or the third IE of helium atom is how much? Minus kz square. Minus in terms of K,
9K.
plus 9K, because energy is minus 9K. So plus 9K, if you give, then it will be knocked out from the ground state to infinite distance. So Li double plus will be converted to Li triple plus. Or you can apply nu bar is equal to k z square 1 by n1 square minus 1 by n2 square. So nu bar, supposing somebody will tell you what is the lambda needed to ionize Li double plus, or what is the lambda of photon required to undertake the third ionization of helium atom. That means to remove the solitary electron in Li double plus. Whatever photon you will apply to dislodge the electron from the ground state, only one electron which is there. So you can directly use the wave equation in giving, K is, RZ square, I'm so sorry, 109677, and this is lithium is 3 square, and 1 by 1 square minus 1 by infinity square. So this will be 0. Go to the infinite distance. So you can find out 9 into 109677, and then the 1. So lambda is equal to 1 by nu bar. So this becomes 10 to the power 8. This is centimeter inverse. So 10 to the 8 into 9 into 10, 1.09677 into 10 to the power 5. So this will be angstrom. So you can get it angstrom and see which reason does it come. This is not any line of the spectrum. For any line, Lyman, Bastian, or corresponding lines in Li double plus, He single plus, those are transition from a fixed cell to the fixed cell, 5 to 2, say 6 to 2, 7 to 2. This is equivalent to Balmer series. If it is hydrogen spectrum, it is Balmer series. But if it is He plus, Li double plus, then it will be equivalent to the Balmer or whatever. So, supposing I'll give you a question and give you some time. Find the lambda of the lowest wavelength line in the Lyman series of hydrogen atom. So the lowest wavelength, is in the in the continuum region. So how can you know unless you apply the you have to make one as infinite distance. So infinite distance, this either K method, the E will be 0. So simply the delta E will be equal to K or Kz square, or if it is He plus, it is 4K, and accordingly you find lambda, or you can use the Rees equation, find lambda of the lowest, because I am talking of the lowest wavelength, because as you continue towards the continuum region, the wavelength decrease in lambda, because the transition energy increases, although the transition energies become very close to each other, still it increases. So that more the energy, less the wavelength. Because as I showed you earlier, this is the energy profile diagram. So this is 1, 2, 3, 4, 5, 6. So this, supposing we're talking about the Lyman series, 2 to 1, the first line, 3 to 1, second line, 3, 4 to 1, third line, 5 to 1, and infinity to 1, this gap, this transition energy. The transition energy becomes close to each other as you go for higher and higher cells. The transition energy, the difference between the higher cell and the first cell, the fixed cell is first cell for Lyman series, right? So, it kemti bahar karibo? Na nu bar is equal to R, supposing it is about hydrogen spectrum. So, it is R, only R will be there. Z square will be 1 into 1 by 1 square minus 1 by, definitely this is from infinity to 1. This is 2 to 1, this is 3 to 1, this is 4 to 1, and this last, the lowest wavelength will be infinity to 1. So this will be infinity square, that means 0. That means I'm talking about, indirectly I'm talking about the ionization energy and the corresponding lambda I am wanting. Either K method, it will be simply K. So if delta E is equal to K, that is K minus 0. That is 0 minus K, because higher minus lower kala K asibo. K method re kale, or eta Rydberg equation answer eta asibo, so that 109677 centimeter inverse. You can convert it to lambda is 1 by nu bar, and tell me what angstrom will be the last one. Can you calculate for me? Yes, Swam? The last one.
Sir, 911.768.
900?
11.
ସେଇଠି ଲଦାଲଦି ହେଇକି ସରିଯାଉଛି, ସେଇଠି ସରିଯାଉଛି। ତାକୁ ଦେଖି ହବନି, ସେ ଲଦାଲଦି ଲିଜନରେ ଦେଖି ହବନି, ବଟ୍ କ୍ୟାଲକୁଲେଟ୍ କରିହବ।
Sir, 768.
ହେଲା। ଶ୍ରୁତି ବୁଝୁଛ? ମିସ୍ ରାଗିଣୀ
Yes, sir.
ଆଜି ସେ ନିହାର ମିସିଂ। that is a difficult, job। ସକାଳୁ ଉଠିବା, ଏକରେ ତ ତମର ସ୍କୁଲ କୋଚିଂ ସବୁ ଅଛି। this is an additional thing which you guys will not miss out. As much coaching you may take, which I do not discourage, but I'm sure we will not miss out, because we know each other, and slowly and steadily you'll know what benefit you'll be getting for those guys who are passionate about learning, not fix the limit। हाँ मु तो नीट ପାଇଁ ପ୍ରିପେୟାର କରୁଛି, ମୁଁ ଏତେ କଥା କାହିଁ ଜାଣିବି। I am not IIT advanced person, I am a NEET person, so ମୋର limit ମୁଁ fix କରିଦଉଛି, ମୁଁ ଏତିକି ଯାକେ ଯିବି। Why? If you have time, why not you learn more? ଆଉ ପୁଣି ସମୟ ଆସିବ। Well, so when we talk about hydrogen spectrum, each line can be expressed either by this Rydberg constant Rz square. For hydrogen spectrum, this is equal to 1. And we can express and the pattern in each spectrum that it hath তিনটা খଣ୍ଡে লাইন দেখাଯିବ then ଆମର ହାତ ଚାଲୁନି then the pattern will overlap. This portion is called the continuum, and this is the pattern for every series. So the Lyman series, as you know, falls in the UV region, and where n1 is equal to 1 and n2 is equal to 2, 3, 4, 5 and so on. I'm not writing anything because the pattern is common to all, but the region is different. UV region repodivo. And if it is Balmer, n1 becomes equal to 2 while the higher cells are 3, 4, 5 and so on. This you know, but I want you to write down in your notes because you are also the beginners. You have to write everything. This is in the past tense series. So where n1 is equal to 3 and the higher cells n2 is equal to the next one onwards 4, 5, 6, and then the bracket series. So n1 is equal to 4, and this falls, I know, I'm sorry, I didn't tell you that Balmer series falls in the visible region, the only series which you can see by arresting on a screen, and also can take the photograph. So this is visible region, and then comes IR region, the first portion of the IR region. Then n1 is equal to 4 and n2 is equal to 5, 6, 7 and so on. This also falls in the IR region, but in a different IR region, in a higher lambda region, which will have a large gap between the Paschen series and bracket series. But once you enter into bracket series, you are going from lower wavelength to higher wavelength, because we have first talked about UV. Then supposing you are going from left to right with increasing wavelength, you will first find the continuum portion in any series. So you have completed the Balmer series, and then after a long distance in the spectrum, distance I'm talking because you are put all the spectrum together in terms of lines in one page. So after a long gap, you will find another continuum of Pastel series. And then you go to increasing wavelength, where the lines will be separated, spread out, and after a few lines, then again blank space comes. After a long blank space, you will find the bracket series. That the continuum will come first, and then it spreads out. Then the P-Font series, when n1 is equal to 5, n2 is equal to 6, 7, 8. And this also in the IR region. And this is the Humphreys series, where n1 is equal to 6, and this is 7, 8, 9, and so on. This is also in the IR region. So when somebody will ask you what is the ionization energy of hydrogen in kilojoules per mole. So whatever calculation we have done, that is in for one atom. So if it will be K per atom, supposing it is 2.18 into 10 to the power minus 18 joule per atom, then per mole it will be 2.18 into minus 18 into 6.022 into 10 to the 23. This will be joules per mole. So for calculation, this value, the per mole value is not used. It is only per atom value is used for calculation. But somebody will ask, supposing per mole, then what will be? It will be, I think, 1300 something.
Sir, 13.12796 into 10 to the power 5 joule per mole.
So if you convert it to kilojoules, then it will be 13. 112.79 into
सर सेତିକି किलो जूल पर मोल
କିନ୍ତୁ ଏଇଟା 1 2 3 4 5 ଏଟା କରିଦେଲେ ଏଠିକି ପଳେଇ ଆସିବ ଏଠିକି ଜୁଲ୍ସ
सर
ହେଇଯିବ।
किलो जूल
ହଁ ଏଇଟା ଯଦି ଜୁଲ୍ସ କରିବ 131279 ଜୁଲ୍ସ। ସୋ ଯଦି ଏଠି ଆମେ 3ଟା ଡେସିମାଲ ଇଏ କଲେ 1312.792 କିଲୋ ଜୁଲ୍ସ ପର ମୋଲ୍ or approximately 1313 kilojoules, approximately 13 or 13 kilojoules per mole. That is the IE per hydrogen, IE per mole of hydrogen. It will be different for the second ionization energy of He plus, which will be 4K. That per mole you have to multiply the Avogadro's constant. So all these you can find out. You also know if we give certain amount of energy to a ground state species, it will go to the fifth cell or sixth cell, all monochromatic radiation. Then you start taking its emission spectrum. You can have several possibilities. I have told you the formula. And also by simple analysis, you can find if it goes to 6, then 6 to 5, 6 to 4, 6 to 3, 6 to 2, 6 to 1. 5 lines. Then you will segregate into which series it falls, taking 1, 1, 1, 1 from every transition. They belong to Lyman 2, 2, 2, 2, 2, 2, 2, Balmer 3, 3, 3, 3, 3, 3, 3, Paston, and so on. And then in some atoms it has already come to 5, then 5 to 3, 5 to 5 to 4, 5 to 3, 5 to 2, 5 to 1. These are the 4 combinations. Then coming to the fourth one, 4 to 3, 4 to 2, 4 to 1. And then coming to the third one, 3 to 2, 3 to 1. And it's 2, 2 to 1. So in this way, or you can use the formula n1 minus n2 into n minus 1 minus n2 plus 1. Yes, am I correct? That is a formula.
Yes, sir. Again, sir.
Then we have to bid goodbye to the Bohr's theory, and you have to solve problems from any book that you get. We bid farewell to the Bohr's theory. And one more question I would like to ask. ଗୋଟେ ପରୀକ୍ଷାରେ ପଡ଼ିଥିଲା ଯେ ଯଦି ଗୋଟେ ଭ୍ୟାଲ୍ୟୁ ଦେଇଥିଲା इलेक्ट्रॉन गोटे पोटेंशियल एनर्जी इन सम सेल as a kinetic energy ଦେଇଥିଲା in some cell of hydrogen atom is equal to ସେ ଗୋଟେ କ'ଣ ଦେଇଥିଲା is equal to supposing x electron volt. Find its potential energy. କିଏ କହିପାରିବ? Yes, Mr. Mohanty.
Sir, minus 2x electron volt.
Precisely he is correct. Because the total energy हम बाहर करथिले हाफ mv स्क्वायर प्रथमे थिला ता जागारे आमे लिखिथिले कोन आउ एठी पोटेंशियल एनर्जी थिला जोटा आमे बाहर करथिले बाय इंटीग्रेशन z स्क्वायर बाय r मु आउ k टाक 1 नउची ए जागारे लिखिथिले mv स्क्वायर जागारे लिखिथिले हाफ z स्क्वायर बाय r तो आमे जानिचे जे काइनेटिक एनर्जी रो न्यूमेरिकल वैल्यू इज हाफ ऑफ द पोटेंशियल एनर्जी but potential energy is negative always, therefore the total energy negative hela. Kinetic energy is never ever negative, it is always positive, but potential energy can be negative, can be because it is losing energy, so it is but when you leave it, then the potential energy will be converted to kinetic energy. It will go away to infinite because there is a lot of attraction and in the first cell. Then if you go to infinite distance, then potential energy will be converted to the kinetic energy. So the double, so x deichi mane the answer will be 2x, and that too minus, because always potential energy is negative. So minus 2x যদি potential energy हुए তাহলে total energy কেতে হবো না x minus 2x is equal to minus x. So kinetic energy jetiki सेति खाली नेगेटिव साइन लगी देले सेटा हे जीवो टोटल एनर्जी ऑफ इलेक्ट्रॉन इन ए पर्टिकुलर सेल जो वैल्यू से देइछ एट दिस पॉइंट ऑफ टाइम आई वुड फील लाइक आंसरिंग मु भाबिथिली डेरी रे कहिबि बोली एबे कहिबाकू भाबुची टू ए क्वेश्चन व्हिच मिस्टर विस्मय त्रिपाठी आस्क्ड व्हाट इज द डिस्टेंस कौन पचारथिलो मिनिमम डिस्टेंस ना कौन पचारथिलो
Distance of closest approach.
डिस्टेंस ऑफ क्लोजेस्ट अप्रोच ये गोटे काठू से शुणी देइछि एटा एक्चुअल को कनेक्शन रे यूज करा जाए मोस्टली रदरफोर्ड गोल्ड फॉयल एक्सपेरिमेंट रे यूज करा जाए हाँ यदि हाइड्रोजन एटम कथा कहबो सेटा तो आम जानी सेटा कौन जे रेडियस आर एन इज इक्वल टू कौन थिला जो कांस्टेंट वैल्यू रो ए नॉट टा होची 0.529 एंगस्ट्रॉम ऊपर n स्क्वायर बाय z सो फर्स्ट सेल रे जदि k सेल टा होची मिनिमम अप्रोच ताले 0.529 एंगस्ट्रॉम इज the distance of closest approach for hydrogen atom. But usually when we talk about distance of closest approach, it is not hydrogen atom. It is the gold foil experiment by Rutherford. What happens? I left it out because this is being taught in a lower level. When a thin gold foil will be hit upon by alpha particles from a radioactive source, polonium, which is emitting alpha particles with a tremendous speed, and it will hit. Though Rutherford found that as expected long before that alpha particles have high penetration power, so they can penetrate straight into thin sheets and go to the other side as if nothing has obstructed it. It will pierce and go straight. जଣା थिला बहुत आगु बेकरेल को काढू maybe 50 years before 100 years before जଣା थिला radioactivity. But what Rutherford found in early 20th century in his famous gold foil experiment, that most of the alpha particles though went straight and produced a strong fluorescence. You know, this is a zinc sulfide screen. It produces when alpha particles or any charged particles fall on that zinc sulfide coating screen, it produces radiations. The brightest spot of radiation was in the straight linear direction. But when he rotated this screen in a circular manner, he also found the glowing of the screen, but to a very low intensity, but glowing. That means some of the alpha particles are being deflected at different angles and falling on the movable zinc sulfide screen, and hence giving some fluorescence, some luminescence, some glow. And to his utter surprise, when he kept it here by stopping this and immediately changing the position of this movable screen, and he found some glow here. The weakest glow was found here in the back side. That means some of the alpha particles are returning back after hitting on the nucleus in this linear way. It is going exactly in the direction of the nucleus. So because of the repulsion, it doesn't hit actually. Because of the repulsion, its straights come back. Piche mood tej chal. 180-degree deflection, it happens. So here, this is gold foil and this is alpha particle. The distance of closest approach means at what distance from the gold, supposing this is a gold atom, its nucleus, and this is alpha particle, which are considered to be point masses. They have mass, they have charge, but they do not have any dimension. They are called point masses. So the distance between the alpha particle, which is going directly in the direction of the nucleus of the gold atom, and after some time it will not go closer then that distance, and it will turn back 180-degree deflection. So that distance, when it returns back, that is called the distance of closest approach. You understand?
Yes, sir.
And you can get easily, I was just trying to keep it for you to save time, that at that time କେତେବେଳେ ସେ ଫେରିବ ନା ଯେତେବେଳେ alpha particle, I am talking about alpha particle, not about gold atom, gold nucleus, nothing, a moving alpha particle, ତାର ଯେତେବେଳେ kinetic energy half mv naught square, this velocity with which the alpha particle is moving, is equal to ଯେତେବେଳେ ଆସ୍ତେ ଆସ୍ତେ ଯାଉଛି, because it is coming closer and closer, there will be alpha particle is plus plus. Unlike electron, which we are talking about so far, alpha particle is nothing but helium nuclei. It is positive, and gold nucleus is positive. So there is huge repulsion. And against that repulsion, it is coming because of the inherent force with which it comes out from the nucleus of a radioactive substance. So inherently, say, as the repulsion body. So repulsion body, so it will be turned into a positive, potential energy. So potential energy धीरे धीरे बढ़िबो गोटे स्टेज रे जतेबेले काइनेटिक एनर्जी से पोटेंशियल एनर्जी समान हे जीवो सेतेबेले आउ जाई परिबो सेतेबेले से रिटर्न करिवो रिपल्सन काठ अधिका गले रिपल्सन अधिका हे जीवो सेही पर्यंत से मूव करिवो आस्ते आस्ते ग्रेजुअली तर वेलोसिटी कमी 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 जीवो एवं मूव करूथिबो जतेबेले वेलोसिटी गोटे एमिति आसीबो जीरो नुहे एमिति आसीबो हाफ एमवी स्क्वायर टा तार जो पॉजिटिव पोटेंशियल एनर्जी संगे समान हे जीवो then it will return back. So आम इक्वेट कलु हाफ एमवी स्क्वायर मुझे पठेबी तुम लिखा दरकार नहीं पठेबी तुम निजे घरे लिखियो किंतु न लिखिले किछि हेई परिबोनी हाफ एमवी स्क्वायर इज इक्वल टू 1/4 पाई एप्सिलॉन बिकॉज़ एसआई मेथड रे कराइछि के जगह रे 1/4 पाई एप्सिलॉन नॉट लिखाइछि and here we take 2e because we are taking of helium, it is 2 units of charge, so 2e into ZE, gold nucleus Z 197, sorry 79, I am so sorry, 79 ta proton achi, Z is 79, talking of Z because you know जो repulsion होची तारा पोटेंशियल एनर्जी गेन करूची अट्रैक्शन हेले पॉजिटिव नेगेटिव पोटेंशियल एनर्जी जोटा होतला हाइड्रोजन इलेक्ट्रॉन टा आस्तला एठी पॉजिटिव चार्ज जाउची so the potential energy becomes positive, so that it is a gain of potential energy, not lose, and that is ZE by R because we have integrated, so this is R naught. So this R naught is the distance of closest approach. We bring it to one side and keep every other thing. So half mv squared semti thibo. So it is the K 1/4 pi epsilon naught 2 ZE square by EK kinetic energy. So more the kinetic energy, less is the R naught. So R naught is inversely related to the kinetic energy and directly proportional to the Z of the gold nucleus, and of course it directly proportional to E square. E square is constant 1.602 10 to the minus 19 coulomb. So where EK is the kinetic energy of the alpha particle, this is used to estimate the size of the nucleus. Nucleus size say tar method alga achi, but the size of the nucleus is always much lesser than the distance of closest. Even आम जदि पॉइंट मास न करिक भाबिबा तार गोटे रेडियस अछि गोल्ड रो न्यूक्लियस रो गोटे रेडियस अछि एवं अल्फा पार्टिकल गोटे जदि पॉइंट मास न भाबिकरी तार गोटे रेडियस अछि सम ऑफ द रेडियस रो प्लूरल होज रेडियाई ऑफ अल्फा पार्टिकल टेकिंग इट टू बी a spherical body and the gold nucleus which is a spherical body तार रेडियस मिसई देले जति का बता टू many times greater than that of the closest approach कारण तार बहुत पूर्वरु से रिटर्न कर जीव रिपल्सन फैक्टर संगरे रिपल्सन संगरे अट्रैक्शन समान हे जाय काइनेटिक एनर्जी संगरे पोटेंशियल एनर्जी समान हे जीव सेते बेले से फेरी आसीबो So the distance of closest approach is much greater than the sum of the radius of alpha particle and gold nucleus. Remember this? Can जे ଦେଇଥିବ data जो ଦେଇଥିବ ସେଇଟା ତମେ କରିପାରିବ. And in fact, Geiger-Marsden experiment that is used to find this distance by experimental method. ମୁଁ ଏଇଟା discussion କରୁନି experiment ଟା, but this is what is done. I think ତମେ ଏଇଆ ଜାଣିବାକୁ ଚାହୁଁଥିଲ ନୁହେଁ?
ଆଜ୍ଞା ସାର୍ ତାପରେ ଗୋଟେ ମାନେ ଥିଲା ଗୋଟେ କମ୍ପ୍ୟୁଟର ତ ସେଇଥିପାଇଁ
ତମେ ଏଣିକି ତମେ କାଇନେଟିକ୍ ଏନର୍ଜି ଯେ ଦେଇଥିବ ଆଲଫା ପାର୍ଟିକଲ ର ସେଟାକୁ ତଳେ ୟୁଜ କରିକି ଗୋଲ୍ଡ କାହା ଉପରେ ମାଡ଼ କରୁଛି ଡେଫିନେଟଲି ଗୋଲ୍ଡ ସେ ଦେଇଥିବ ସେ ତାର Z97 ଇ ର ତ ସବୁବେଳେ ଫିକ୍ସଡ କରିକିରି ଇପ୍ସିଲନ୍ ନଟ୍ 1/4 ପାଇ ଇପ୍ସିଲନ୍ ନଟ୍ ର ଭ୍ୟାଲ୍ୟୁ ଇଜ 9.10⁹ value 9 into 10 to the power 9 is very close to 9. ଦେଖିଛ ନା ନାଇଁ ଲେଖିଛ डायरेक्टली 1/4 पाई इप्सिलॉन ର ଭ୍ୟାଲ୍ୟୁ ଟା ମନେ ରଖିବାକୁ ପଡିବ କାରଣ ଏଟା 12 କ୍ଲାସ ର କୋର୍ସ ରେ ଅଛି ତେଣୁ ଏବେ କିନ୍ତୁ
k ର ଭ୍ୟାଲ୍ୟୁ ସମାନ
ସେ k ର ଭ୍ୟାଲ୍ୟୁ ଇନ୍ SI is
9 into 10 to the power 9 newton meter
Yes.
square per
9.
coulomb square.
Yes, you are correct. You are correct. Yes. 9 into 10 to the power 9 meter square per Newton per Coulomb square. Yes. Okay.
Yes, sir.
Okay. With this, we will now go for matter waves. Under 15 minutes. Amar hei pariboni aji. Hoop. Schrödinger equation next time kariba. Matter waves and de Broglie equation. De Broglie choto lekha jay. Now, opposite to electromagnetic waves which are अच्छा गोटे क्वेश्चन मु देइछि तुम देखिथिबो फोटोन एठी मैं काटी दोछि फोटोन इलेक्ट्रोमैग्नेटिक वेव्स एक्सरे हो यूवी हो जहाँ भी हो तार रेस्ट मास 0 किंतु जे जाउछि जेतेबेले तार मोमेंटम अछि तार से गोटे इलेक्ट्रॉन को हिट करिकि नॉकआउट कर दे पाउछ तेन तार मोमेंटम अछि तेणु मोमेंटम अछि बोली तार गोटे रिलेटिविस्टिक मास अछि photon is not equal to 0 non-zero rest mass ta 0 supposing it is you presume that it is at rest rahiboni kebe rest re rest mass kuha jaye hypothetically rest mass 0 jodi rahibo ame ojon jantra dhari kri ojon kariba tar mass naba se 0 bariu kintu ar relativistic mass ଅଛି relativistic mass ମାନେ ଯେତେବେଳେ ତମେ ମୁଭ୍ କରୁଛ ସେତେବେଳେ and in any case तब relativistic mass बढ़ी जीवो and that mr is equal to m naught by 1 minus v square v by c रो square एटा c होची the ultimate velocity that is velocity of light as हमें कहू but actually it is velocity of all electromagnetic waves in vacuum or in air. So that is 3 into 10 to the power 8 meter per second. And v supposing तमे ये करिवो भेलोस तमे निजे जो मूव करूछ कि जेट इंजिन मूव करूची सेटा इते मैसिव जणा पड़िबनी माइक्रोस्कोपिक पार्टिकल लाइक अल्फा इलेक्ट्रॉन प्रोटॉन एमानकर मास को पकई कि देखिबो जे जेते अधिका अधिका वेलोसिटी दबो v टा जदि c पाखापाखि आसीबो धर v is equal to 1/3 of c. So the relativistic mass the mass बढ़ी जीवो रिलेटिविस्टिकली तुम धर से गोड़े जीव तराजू नहीं करी ओजन जंत्र नहीं करी गोड़े जीव तो थोब चलला अवस्था देखिए तार ओजन बढ़ी जाइए माने वस्तुत्व बढ़ी जाइए दैट इज कॉल्ड रिलेटिविस्टिक मास so that will be 1 minus এটি 1/3 cc কটিগলা 1/9 so কেতে হবো
Sir, 9 m0 by 8.
so it will be more than 1 point something m0 so its rest mass ଠାରୁ ଅଧିକା ହେଇଯିବ and as it becomes equal to c ଯଦି ହେଇପାରିବନି it will violate the Einstein's principle of relativity supposing c ସାଙ୍ଗେ ସମାନ ହେଇଗଲା can come very close to c 99.9999% କୁ ଆସିପାରିବ କିନ୍ତୁ exact c ହେଇପାରିବନି ତାପରେ ଅଧିକା ଏନର୍ଜି ଦେଲେ ସେଇଟା ତାର କନଭର୍ଟେଡ ହେଇଯିବ ମାସ୍ ଭେଲୋସିଟି ଏଇଟା ଯଦି c ଧର ବି ଏଟା କଟିଗଲା c by c କଟିଗଲା so କଣ ହେଇଗଲା ସେଠି ୟୁଜ ହେଇପାରିବନି
Sir, infinite ହେଇଯିବ.
But infinite 1 minus 1 0 ହେଇଗଲେ something infinitely large ହେଇଯିବ it cannot be determined it will be in a general sense it will be infinitely large ସେଟା ତ ହେଇପାରିବନି it will violate Einstein's relativity principle so ଯଦି very close to ଆସିଲା 99.9% ଆସିଲା so the relativistic mass will be very very high तो ସେଇଟା ଏଇଟା 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 ରିଲେଟିଭିଷ୍ଟିକ୍ ମାସ୍ କେମିତି ଆପ୍ରୋଚ୍ କର ବାହାର କରିବ ଏଇଟା ଆଇନଷ୍ଟାଇନ୍ସ ଇକ୍ୱେସନ୍ ତମେ ହଁ ମୁଁ କ'ଣ କହୁଥିଲି ଯେ ଫୋଟନ୍ର ଯେଉଁ ଅଛି ଆଉ ଗୋଟେ ଯେଉଁ ଥିଓରି ଅଛି E is equal to mc ସ୍କୋୟାର ଯେ ମାସ୍ ଯେତେବେଳେ ଏନର୍ଜିକୁ କନଭର୍ଟ ହେଇଯିବ ଯେତେବେଳେ ଏଇ ଇକ୍ୱେସନ୍ରେ କନଭର୍ଟ ହବ mass is nothing but a concentrated form of energy as the physics people will say material scientists will say that mass Swayamjit is nothing he has 55 or 50 kg mass but that is nothing but a concentrated form of energy so energy and mass they are interconvertible ତେଣୁ ମ୍ୟାଟେରିଆଲ ସାଇଣ୍ଟିଷ୍ଟ ମାନେ ଯଦି ସବୁ ଜିନିଷକୁ ସେମାନେ କ'ଣ କରନ୍ତି ନା ଏନର୍ଜି ୟୁନିଟ୍ରେ ପ୍ରକାଶ କରନ୍ତି ସି ସ୍କୋୟାରରେ ଗୁଣିକିରି ତାକୁ ଇଲେକ୍ଟ୍ରନ ଭୋଲ୍ଟ କରିକିରି ଗିଗା ଇଲେକ୍ଟ୍ରନ ଭୋଲ୍ଟ କରିକିରି ଗିଗା ଇଜ 10⁹ ମେଗା 10⁶ ଗିଗା 10⁹ GeV କରିକିରି କରନ୍ତି ଅତ୍ୟଧିକ ଯଦି ପାର୍ଟି କରିବାରେ ମାସ୍ ପରା ସେଥିପାଇଁ ସେ କ'ଣ କରିଦିଅନ୍ତି GeV ବାଇ ସି ସ୍କୋୟାର ଅଖା ଦଉଥାଉ ଗୁଣ ଦଉଥାଉ सी स्क्वायर गुणिक एनर्जी करछंती तमे जदी बेसी पार्टी करियो बाई सी स्क्वायर कर देबे सने कोन तमे ऑटोमेटिकली ताको कन्वर्ट करिकरी तमे मास केजी रे पाई जिवो कि केजी रे पाई जिवो सो ए प्रिंसिपल यूज करंती एंड प्लैंक्स क्वांटम थ्योरी होची कोन hc बाई लैम्बडा सो एटा होची सो प्लैंक्स क्वांटम थ्योरी से समान कर देले वर्तमान बाहर करिवा रिलेटिविस्टिक मास सो एटी सी गोटे कटिगला मु फोटोन कथा कहूँ से मु नेबी तुमको मैटर वेव को एटी मु फोटोन रो मास मास इज इक्वल टू कौन हम ना एच बाय एम टा सी टा तलू को आसीबो कौन हम
Sir, h by lambda c.
सो एटा हम फोटोन रो रिलेटिविस्टिक मास तो बाहर करि परिबो 6.626 into 10⁻34 लैम्बडा देथिबो सिए जे फोटोन रो लैम्बडा देथिबो ना लैम्बडा विल गिवन टू यू लैम्बडा माने नॉट दैट से मोर मनो इच्छा कहबो जे एई मोनोक्रोमैटिक रेडिएशन रो जो तार लैम्बडा एति कि तार रिलेटिविस्टिक मास केते एंड लैम्बडा into c3 into 10⁸ सो लैम्बडा टा मीटर रे बाहरला ताको तुम एंगस्ट्रॉम करि पारलो 10⁻10 मल्टीप्लाई कर देला एंगस्ट्रॉम हे सो तार ए सॉरी इट लैम्बडा भरछु ना आई एम सो सॉरी इठी केजी रे बाहरिबो लैम्बडा टा तुम सब कन्वर्ट करिवो ये को से एंगस्ट्रॉम रे देथिले ताको सेंटीमीटर करिवो किबा इठी जेहेतु इठी एडी यूज करछ मीटर करिवो एंगस्ट्रॉम देथिले 10⁻10 रे गुणिकरी ताको मीटर करिवो एंड एटा मीटर पर सेकंड अछि एटा जूल्स इनटू सेकंड अछि कटि काटि करी जूल्स सॉरी केजी रे बाहरी ऑटोमेटिकली कटिबो नहीं बट दैट विल बी इक्विवेलेंट टू केजी बिकॉज यू आर डूइंग ऑल इन एसआई यूनिट सो केजी रे बाहरिबो सो केजी होछि एतिकी केजी होछि तार रिलेटिविस्टिक मास फोटोन रो photon ame kohuche it doesn't have any rest mass, but it has a relativistic mass because it has a momentum. Tadre v c guni dele mc, that will be the momentum of the photon, of that photon we are talking about. It varies from photon to photon. Mass varies. Relativistic mass also varies from photon to photon. Hence, their momenta also varies. Now, coming back to matter waves, de Broglie कहले कौन जो तमे उल्टा फोटोन को तमे कहूच तार मास नहीं, आमे सिना बाहर करदेले किंतु मास तार नहीं, मासलेस पार्टिकल्स ताकू कहूच से वेव रे जाउची, ए सॉरी से वेव रे एक्चुअली खाली वेव सेटा तमे कहूच नहीं नहीं डिस्क्रीट पार्टिकल्स, अलगा 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 डिस्क्रीट पार्टिकल्स अच्छी ताकू फोटोन तमे कहलनी, तो पार्टिकल नेचर ताकू देलनी, डुअल थ्योरी तमे वेव्स को देलनी, आई मीन इलेक्ट्रोमैग्नेटिक वेव्स को देलनी, रियल वेव्स को मु उल्टाटा कहूची. Material particles, microscopic particles, particularly macroscopic particles रा किसी significance नहीं. It is valid for microscopic particles like moving electron, moving alpha particle, which are very fast moving, comparable with the speed of light. Microscopic particles moving with high speed. You know, exhibit wave motion. Ultata. They exhibit wave motion. They show wave nature. Wave ଯେମିତି light waves ର interference pattern, diffraction pattern ଆମେ ପାଇପାରୁଛେ, ମୁଁ ଦେଖେଇବି ସେଟା. Exactly ସେମିତି इलेक्ट्रॉन बीम को नेइकरी से पुणी सेमती गोटे जिंक निकेल सल्फाइड गोटे 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 भल क्रिस्टाल उपरे स्लांटिंग वे रे माड़ कले सॉलिड स्टेट तो उठी जाइछि. तेणु इन द क्रिस्टल देयर आर सो मेनी प्लेन्स, क्रिस्टलोग्राफिक प्लेन्स, पैरेलल प्लेन्स. सो इंक्लाइंड रे माड़ करा जीवो. एक्सरे यूवी एमाने तो रियल इलेक्ट्रोमैग्नेटिक वेव्स. एक्सरे रो माड़ कले से रिफ्लेक्ट करिवो फ्रॉम डिफरेंट पैरेलल प्लेन्स, एटम संगे हिट करिकरी से रिफ्लेक्ट करिवो. एवं ब्रैग्स इक्वेशन तार अछि, सो आमे पढिवा सेटा को ए एटम ए ये रे सेटा कोठी पढ़ा जाए ब्रैग्स इक्वेशन ता सेही सॉलिड स्टेट रे ना आजकल तो उठी गला. सो जाई करी तो रिफ्लेक्ट करिकरी जीव मल्टीपल पैरेलल रेज माड़ करिकरी क्रिस्टल रु जीव सेते तांको भीतर इंटरफियर हो. जदि दीटा वेव कि तीनटा वेव पांचटा वेव से माने तांकर फेज समान हे गला, ये भी क्रेस्ट रे अछि, ये भी क्रेस्ट, ये भी क्रेस्ट, तो इंटेंसिटी मिसी जीव, ताको कहंती कंस्ट्रक्टिव इंटरफियरेंस. दैट विल गिव ए ब्राइट स्पॉट. आ जदि बाय चांस आ गोटे जगह रे यार क्रेस्ट थला लुक तार ट्रफ, तो ये लाइट इंटेंसिटी तार लाइट माने मु यूज कर जनरल टर्म, आर इंटेंसिटी तार इंटेंसिटी दे विल एक्जेक्टली कैंसल से जगह रे किछि लाइट पडिबोनी. सो इट विल बी डार्क स्पॉट. सो सेटा आगुरु जणा थिला, दैट इज कॉल्ड एक्स-रे डाइफ्रैक्शन pattern. Will be containing alternate dark rings and then bright rings. Dark माने सेठी ताको कहते destructive interference, जोठी पडिबोनी लाइट. लाइट बा जेकोन से एक्सरे तक तो फोटोग्राफिक प्लेट रे डेवलप करा जीवो ना, पडिबोनी. सो destructive interference माने तो क्रेस्ट संगरे यार ट्रफ एका समय आसीबे, एका मोमेंट रे यार क्रेस्ट को यार ट्रफ सेतेबेले they will cancel, and that is called destructive interference. So it will give you a dark ring and bright ring. Dark ring, bright ring एमती ए पैटर्न टा कहंती एक्स-रे डाइफ्रैक्शन पैटर्न. जणातला को काळू या आउ जने साइंटिस्ट आसीले सेही समय रे डी ब्रॉग्ली को हेल्प करिया पई, जेमती बोर हीरो होई गले का पई ना रिडबर्ग से रिडबर्ग को जे रिडबर्ग सेतले को कैलकुलेशन करथिले आर रो वैल्यू टा, किंतु असल बाल्मर सीरीज जो करदेले पास्ट ए जो सॉरी जो प्लैंक ब्लैक बॉडी रेडिएशन करके ताको थ्योरी दे देले जे एवरी फोटोन इज सिंगल 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 एंड इट इज वैल्यू इज E इज इक्वल टू h न्यू. सेटा से कोन कर देले बोर डेल्टा E इज इक्वल टू h न्यू कर देले, खाली E टा डेल्टा D कर देले, बिकॉज़ इट इज ट्रांजिशन फ्रॉम ए फिक्स्ड सेल टू फिक्स्ड सेल, फ्रॉम ए हायर टू लोअर फॉर एमिशन, लोअर टू higher is absorption. So say Davisson and Germer, these are the two scientists. ए माने कौन खोले एक्सरे जगह रे गोटे कैथोड रे ट्यूब रु इलेक्ट्रॉन बीम आनिले, which is also traveling very close, not exactly as C. X-rays are moving with C. Velocity of light sange saman, exactly saman. Kintu electron beam is not traveling with C, but it is close to C. So the matter called same the slanting way in a nickel sulfide screen and took the diffraction pattern in a photograph. He found the same pattern. Therefore, he suggested that definitely electron beam would occur. They are showing wave motion because the interference diffraction is a wave phenomenon. It is a property of the wave which electron beam is showing. Tapare neutron beam niagala. Neutron beam niagala exactly same pattern. X-ray diffraction pattern bala neutron diffraction pattern, electron diffraction pattern was the same pattern. Seitu de Broglie kara sahasa badhigala. Se kale no, every microscopic particle moving with high speed will exhibit wave motion. That is called matter waves. Takui kaunti matter waves, which is significant for microscopic particle but insignificant for macroscopic particle. So electron diffraction. So note टा तमे लेखिबो मु देई देबी अंक करिवे वर्तमान pattern same similar to the X-ray diffraction pattern. Okay. So से केमती कले ना दीटा को थ्योरी को आइंस्टाइन थ्योरी एमसी स्क्वायर मु जोटा कली एटा आइंस्टाइन्स रिलेटिविटी थ्योरी इज इक्वल टू एच सी बाय लैम्बडा. सो सेठी एम बार करथले एठी लैम्बडा बार करबा. सो सी गोटे कटिला. सो एच बाय एम सी एटा फोटोन पाई किंतु से कौन कले सी वाज रिप्लेस बाय वी काई material particles C exactly C हबनी C टू कम हब. So it may be C by 3, C by 4, C by 9, whatever C. So V term द्वारा से ये कले चेंज कर देले. So lambda is equal to H by mv or H by p, where V is the velocity of the material particle जे move करूची, which is never equal to C. V is the velocity of the material particle. And mass m is the mass कहवा बाहुल्य, p is the momentum, linear momentum of the particle. So this is the famous de Broglie equation. So lambda आकु जदि आमे कौन करिबा ना टिके हाफ एम स्क्वायर फॉर्म रे पकेबा 2 रे गुणिबा नहीं आकु स्क्वायर कर दवा चलो एच स्क्वायर एम स्क्वायर वी स्क्वायर कर दवा चलो. सो जेहेतु आमे काइनेटिक एनर्जी को कन्वर्ट करिया चाहिबा सो एच स्क्वायर बाई गोटे 2 रे गुणिबा गोटे एम रखिबा बाहर एटी हाफ एम वी स्क्वायर गोटे कर दवा एटा जगह आमे लिखिबा के ई बाई के. सो लैम्बडा will be equal to पुणी स्क्वायर रूट हो पुणी एच हो रूट ओवर हो 2MEK. यहाँ गोटे इक्वेशन यूज करा जाए डायरेक्टली नोइंग व्हाट इज द लैम्बडा ऑफ द मैटर वेव. ये फोटोन वर्ड यूज करनी मैटर वेव, इलेक्ट्रॉन वेव और प्रोटॉन वेव और अल्फा पार्टिकल वेव और एनी मैटर वेव when its kinetic energy is this much. Directly you can use it for that. You know, so more is the kinetic energy, less is the lambda. एटी देखुछ जेमती velocity संगरे mass तो fixed, s तो fixed, so velocity संगरे inversely proportional. जिते अधिका स्पीड रे जीवो लैम्बडा मैटर वेव तार जो लैम्बडा ऐसे छोटो छोटो हेगी जीवो. सेमती या संगरे काइनेटिक एनर्जी संगरे रूट काइनेटिक एनर्जी संगरे प्रोपोर्शनल, इनवर्सली प्रोपोर्शनल. सो लैम्बडा is inversely proportional to V, inversely proportional to a root over of EK. Other factors are constant mass, H, M, you have to take rest mass. Every particle has a relativistic mass, but here you have to take the rest mass. Don't take relativistic mass for calculation. So, सबुठु मजा जिनस होला एटा को यूज करी de Broglie prove कले the quantization of angular momentum which was merely a hypothesis or an assumption by Bohr সেটা prove ହେଇଗଲା proved କେମିତି prove ହେଲା ଯେ ଯେତେବେଳେ ଜଣା ପଡିଲା ଇଲେକ୍ଟ୍ରନ୍ ଇଜ ଏ ୱେଭ୍ ଏମିତି ଚିତ୍ରଟା ଭୁଲ ହେଇଗଲା ଯୋଉ ବୁଲୁଛି ସେ ଗୋଟେ ୱେଭ୍ ମୋସନରେ ବୁଲୁଛି ତାର ଲାମ୍ବଡା ବି ଅଛି ଇଲେକ୍ଟ୍ରନଟା now we were talking about electron moving or alpha particle moving in straight line it is also moving in a wave motion wave nature wave pattern but electron is moving in a circular orbit so far we have not entered into orbital hoop re padiba the orbit fixed jo track that fixed track is not acceptable it's a space so se jinso shape of the orbitals kemti calculation hala se सब jinso देखिया so jodi electron wave he gala bartwan electron is a wave it is called a matter wave electron is a material particle so it's forming ei kintu kono तार वेवटा गोटे स्टैंडिंग वेव चली जब तक रहेगा चांद और सूरज सेम चलती तार लाम्बडा कांस्टेंट तार फ्रिक्वेंसी कांस्टेंट सबू कांस्टेंट बट इट इज ए वेव से आम जो एमती गोल बुलाऊले सेटा गोटे हाइपोथेटिकल तारी गोलटा हूँ तार गोटे आउटलाइन तारी दिहरे सी एमती वेव फॉर्म अच्छी मुझे करदेली अच्छी ये गोटे वेवलेंथ ये गोटे वेवलेंथ तीन टा वेवलेंथ आ भितर अच्छी सो এই जो स्टैंडिंग वेव बा स्टेशनरी वेव कहते स्टैंडिंग और स्टेशनरी वेव तार प्रिंसिपल है जे द एंटायर सर्कमफरेन्स 2 पाई r शुड बी ए होल नंबर मल्टीपल ऑफ लैम्बडा 2 लैम्बडा कि 3 लैम्बडा कि 4 लैम्बडा कि 5 नहले ये जदि एटा हला कोन ना रेगुलर पैटर्न हला किंतु सिमेट्रिकल पैटर्न हम चलो स्टैंडिंग वेव किंतु जदि एमती करी एटा न पड़ा ये पड़ा ये पड़ा यार सो जदि ये एनटा होल नंबर नहला देन दे विल डिस्ट्रक्टिवली इंटरफियर तापर धीरे 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 एम्प्लीट्यूड कमी 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 से फ्लैटेंड एंड दैट विल बी नो वेव नेचर बट वेव नेचर तो अच्छी प्रूव्ड बियॉन्ड एनी डाउट बाय डेविसन एंड जर्मर दैट मटेरियल पार्टिकल moving either in a circular motion or in a linear motion they move they give wave motion they exhibit wave motion तार wave nature अच्छी तेणु स्टैंडिंग वेव रो गोटे रिक्वायरमेंट हला से द एंटायर पाथ लेंथ गोटे सर्कुलर ट्रैक रे से जाउची जदिओ से एक्जाक्टली नॉट फॉलोइंग द सर्कमफरेन्स इट इज अप गोइंग अप एंड डाउन तार एंटायर जो पाथ लेंथटा शुड बी ए होल नंबर मल्टीपल ऑफ लैम्बडा फॉर स्टेशनरी वेव वर्तमान जदि आमे पुट करिबा लैम्बडा जगह रे डी ब्रोग्ली इक्वेशन h by mv तेबे आमे आराम रे पाई परिबा जे mvr को रखिबा एठी की एंड 2 पाई को नहीं आसीबा n h by 2 पाई n h by 2 पाई हाँ कि नहीं n h by 2 pi so this is the assumption of Bohr which was proved by de Broglie equation de Broglie जो प्रमाण तंकर हेगला Davisson and Germer जेतबेले कहि देले तंकर इक्वेशन टा वैलिड हेगला एवं सेही थ्रू से डिराइव कले जे बोर को assumption नुहे it is true that lambda it is a stationary wave तेणु first n is equal to 1 हेले mvr is equal to h खाली h by 2 pi h by 2 pi को मु कहि h क्रॉस कहि तो
आज्ञा सर
ताको h प्लस कहते सो n is equal to 1 हेले the entire circumference is equal to 1 lambda n lambda तो there is only 1 lambda बा गोटी lambda ता माने तार जदि वेव पैटर्न टाको हमें विजुअलाइज करबा कि देखुची कि फोटो नहीं से गोटी डीप आ गोटे मुझे गोटे ये कर सो एटा क्रेस्ट एटा ट्रफ रु ट्रफ को आसो गोटे वेवलेंथ आसला गोटे ट्रफ गोटे क्रेस्ट हेले गोटे वेवलेंथ अच्छी सो आई यूज टू फनीली से जे वेव पैटर्न इन द फर्स्ट सेल इलेक्ट्रॉन वेव पैटर्न इज जस्ट लाइक लुकिंग लाइक ए लंका आंब But when you go to the second cell, the wave pattern will look like, this will be 2 lambda. N will be equal to 2. So second cell jodio tike durare achi, but there will be 2. So it will be like ମୁଁ ଗୋଟେ ଜାଣିକିରି ଇଏରେ କରୁଛି। ତ ଏଇଟା କ୍ରେଷ୍ଟ, ଏଇଟା କ୍ରେଷ୍ଟ, ଏଇଟା ଟ୍ରଫ୍, ଦୁଇଟା ଟ୍ରଫ୍, ଏ କ୍ରେଷ୍ଟରୁ ଏ କ୍ରେଷ୍ଟ ଗୋଟେ ୱେଭ୍ ଲେନ୍ଥ, ପୁଣି ଏ କ୍ରେଷ୍ଟରୁ ବ୍ୟାକ୍ ଟୁ ଏ କ୍ରେଷ୍ଟ ଦୁଇଟା ୱେଭ୍ ଲେନ୍ଥ ଏଥିରେ ଅଛି। ଲୁକ୍ସ ଲାଇକ୍ ଏ ପି ନଟ୍। ପି ନଟ୍ ମାନେ କ'ଣ, ଚୋପା ଖୋଲି ନଥିବ, ଚିନାବାଦାମ, ଏଇଟା ଲଙ୍କା ଆମ୍ବ, ଚିନାବାଦାମ, n is equal to 3 ମାନେ Indian paratha. Now see, this is the circumference will be having, will accommodate 3 standing waves, full waves 3टा ରହିବ ତା ଭିତରେ, and जब तक रहेगा चांद और सूरज तब तक वो रहेगा। So it will be 1 2 3, ये गोटे लंबड़ा, ये गोटे लंबड़ा, so it will look like an Indian paratha. And then if it n is equal to 4, then 2 pi r is equal to 4 lambda, and ସେମିତି କରିପାରିବ। it will be looking like କ'ଣ ଗୋଟେ octopus ନା କ'ଣ ଗୋଟେ, ये ଗୋଟେ wavelength, ये ଗୋଟେ wavelength, ये ଗୋଟେ wavelength। So this is the thing, I that is now time to wind up। ମୁଁ ସେ ଯୋଉ ଫାଇଲଟା ଦେବି ତମକୁ, ସେଇଟା ତମକୁ ମୁଁ ଦେଖୁଛି। এইটা ଗୋଟେ ଗ୍ରାଫ କରିବ। ଆଉ ଗୋଟେ କଥା ଯୋଉଟା ଅଙ୍କ ପଡ଼ିବ, ଯଦି ଗୋଟେ ଚାର୍ଜ ଇଲେକ୍ଟ୍ରନ୍ ଧର, ତାର ଚାର୍ଜ ହେଉଛି ଇ, ସେ ଗୋଟେ ପୋଟେନ୍ସିଆଲ ଡିଫରେନ୍ସ ଅଛି, ପିଡି ହେଉଛି ପୋଟେନ୍ସିଆଲ ଡିଫରେନ୍ସ, 10 ଭୋଲ୍ଟ 15 ଭୋଲ୍ଟ ରେ ସେ ମୁଭ୍ କରୁଛି, ଇଲେକ୍ଟ୍ରନଟା ହେଲେ ନେଗେଟିଭ ରିପେଲ ହେଇକି ପଜିଟିଭ ଆଡ଼କୁ ଯାଉଛି, ମୁଭ୍ କରୁଛି। ତାର ଯୋଉ kinetic energy habo, the work done is converted to kinetic energy। so work done kete na v into q, tame 10th class रे तुमको पढ़ाई छी जे चार्ज e into voltage, जो voltage under रे से move करूची सेटा होची v into e, v into q, q माने एठी e, so that is the work done and that is converted to this kinetic energy। so एटा मध्ये अंक रे पडिबो, and we have lambda, এইটা গোটে আমি কোটু বাহার করছু, হ্যাঁ এই যে ইকে লিখিলে আগরু, ইকে জায়গায় আমি ই ভি লিখিবা। ই ইজ দি চার্জ অফ यूनिट चार्ज, इलेक्ट्रॉन रो चार्ज, and v is the voltage, not anything, voltage under which it is moving। so आमे जदि रूट ओवर v टाको एपट को नहीं जीवा, so the lambda of the matter wave into the root over of the voltage under which it is moving is equal to h by 2me। this is a constant, just like pv is equal to constant Boyle's law। so in that case the graph between root v and lambda will not be linear, it's not a linear equation, the graphs will be curve, and since they're inversely related, so it will be negative slope every time, slope will be with increase in lambda, the slope, instantaneous slopes will be decreasing। and these are the two graphs for two different particles with different masses, and you can mathematically see that this A graph which is lying below will have a greater mass, because mass is in the denominator here, and the graph which is above that corresponds to the material particle which is having lower mass। so you have to write all these things, and this is the famous X-ray diffraction experiment which was found to be exactly mimicking for electron diffraction। so here electron beam is taken, electron gun from a cathode ray tube, we make an electron gun, high speed electron beam is striking on a nickel, it's a nickel crystal, I'm sorry, not nickel sulfide, nickel crystal, then after reflection through different parallel planes coming lying below and below and below, so then they come out, they go for constructive as well as destructive interference at different distances, They give alternate bright rings and dark rings, and that is the typical X-ray diffraction pattern. That was found to be the exact case with electron diffraction. So it was proved that particularly macroscopic particles with moving with high speed, they show wave motion. So this we have already done. There is nothing we have done. This is n is equal to 1 is like looking like এটা লঙ্কা আম্ব, এটা চিনাবাদাম, Indian paratha, whatever. And what is the distinction between matter waves and electromagnetic waves? এটা भी करियो. Electromagnetic waves ମାନଙ୍କ rest mass 0, কিন্তু matter waves ର rest mass ଅଛି non zero. Electromagnetic waves रे दीटा को field ଅଛି, magnetic field ଅଛି, electric field ଅଛି, ତେଣୁ କରି ତା ନାଁ ହେଉଛି electromagnetic waves. কিন্তু এইটার ইলেকট্রিক ম্যাগনেটিক ফিল্ড থাইপারে ন থাইপারে। ধর নিউট্রন মুভ করুছি, নিউট্রন ইজ নিউট্রাল পার্টিকল, ইট ইজ নট প্রডিউসিং এনি ফিল্ড। অফকোর্স নিউক্লিয়স ভিতরে নিউট্রন ইজ হ্যাভিং এ ম্যাগনেটিক ফিল্ড, বট নিউট্রন যাଉଛି বিম হিসাବରେ যাଉଛି, ইট ডজন্ট প্রডিউস এনি ফিল্ড। So matter waves may or may not. So electron move କରୁଛି, yes, a moving charge is producing a magnetic field. Moving alpha particle, moving proton, they produce magnetic field. But moving neutron does not. Electromagnetic waves do not carry mass, rest mass, but the rest mass of photon is 0. But matter waves, they carry a non-zero rest mass. Electromagnetic moves, all of them move with velocity c, but rest mass, matter waves particle गुड़ाक, real particles गुड़ाक, they cannot move with c, they have to be less. And आमे ताकू decide करिवु केते acceleration आमे दउचे, ताकू दबा in a synchrotron. In a synchrotron device आमे केते ताकू volt तारे actually तारा velocity बढ़ा जाए by using magnetic field and electric field continuously. तार केते velocity acceleration बढ़ई करी आमे केते velocity आमे reach करिवा आम हाथ रे एटा अछि, material particle आम हाथ रे अछि. So but cannot be equal to c. এটা গলা আর ইলেকট্রোম্যাগনেটিক ওয়েভস পাই lambda is equal to c by nu, constant. Lambda and nu, they are inversely related, and the constant of proportionality is c. But here lambda is h by mv. The de Broglie equation is used. And a numerical kolo, calculate the de Broglie wavelength of an electron moving with speed 5 times 10 to the power 6. So এটা কেতে হবো यूज करिबो, मु फटकिन कर दउची लैम्बडा इज इक्वल टू h by mv, h 6.626 into 10 to the minus 34 joule into second. Mass of electron is 9.1 into 10 to the power kete minus 31 kg. The velocity se देइची 5 into 10 to the power 6 meter per second. So ultimately meter रे बाहरिबो लैम्बडा जहाँ बाहर एति मीटर रे, ताकू एंगस्ट्रम कर दो पड़िबो 10 to the 10 रे मल्टीप्लाई करिवो, सो एंगस्ट्रम रे कन्वर्ट करिवो, देखिवो जहाँ बाहर भी एंगस्ट्रम रे, that will have some value. इलेक्ट्रॉन अल्फा पार्टिकल की ये बन करो डायमेंशन एक्चुअली नहीं, देयर पॉइंट मासेस ताकू धरा जाए, से सिग्निफिकेंट जहाँ भी वैल्यू बाहरला सिग्निफिकेंट. किंतु गोटे बुलेट जदि आमे बुलेट पई कैलकुलेट करिवा, 5 ग्राम बुलेट मूविंग विथ सेम स्पीड, सेम पाखापाखि सेम स्पीड रे, तार जो लांबड़ा बाहरिबो एते स्मॉल जे बुलेट बुलेट रे गोटे डायमेंशन अछि, जेते छोटो हेले भी तार डायमेंशन अछि, इट इज ए माक्रोस्कोपिक पार्टिकल. तो ता तुलना रे एते इनसिग्निफिकेंट, तार वेव मोशन आमे देखिबा को पाइबानी, कोनोसी जंत्र रे ताकू धरि परिबानी. सो इट इज मीनिंगलेस टू टॉक अबाउट मैटर वेव्स फॉर लार्ज पार्टिकल्स, माक्रोस्कोपिक पार्टिकल्स. तो एटा करिवो एवं प्रमाण कर दबो जे फॉर माइक्रोस्कोपिक पार्टिकल इज इट इज रेलेवेंट, फॉर मैक्रोस्कोपिक पार्टिकल इज इररेलेवेंट बिकॉज इट्स डायमेंशन is high compared to lambda that you calculate. But for electron and other microscopic particles, जोटा भारी एंगस्ट्रॉम रे, जेमति बेगर हैज नो चॉइस, तेणु इलेक्ट्रॉन तो इलेक्ट्रॉन प्रोटॉन जा तो किसी मास नहीं ए सॉरी डायमेंशन नहीं लंब प्रस्थ उच्चता नहीं आम जदिव रेडियस बाहर करूँ आम ट्रीट करूँ एज ए पॉइंट मास तापाई जहाँ बाहर that is greater than its dimension, so it has a meaning, and that too we have already experimentally proved, not we but Davisson and Germer and many others. But तुम कौन मूविंग बुलेट को पूरेब क्रिस्टल रे पूरे बाहर कर तार डिफ्रैक्शन पैटर्न इम्पॉसिबल कैरिंग सो एगुड़ा कहला एटा मु ऑलरेडी कहि सारलेनी रिलेटिविस्टिक मास मोमेंटम ऑफ फोटोन ऑलरेडी हमें कैलकुलेट कर सारे कैलकुलेट करिवो सो कंक्लूजन हला इलेक्ट्रॉन इज ए वेव सो बर्तमान वेव मेकानिक्स आरंभ हला इलेक्ट्रॉन टा वेव हला परे हाइजेनबर्ग हमें नेक्स्ट टाइम पढ़िबा कांसेप्ट चेंज कर देबे वेव तो ठीक अछि किंतु गोटे निर्दिष्ट कक्ष रे बोलिबे स्पेस रे बोलिबे प्रोबेबिलिटी फैक्टर आसी जीवो तेणु तापर स्क्रोडिंजर आसी जीवे वेव इक्वेशन देबे ए असाइनमेंट होची एई चैप्टर रो करिवो सो हमें पुणी बुधवार दिन बुधवार कहूँ आमर सोमवार दिन तो क्लास हो ना माने कौ सोमवार दिन एपर्यंत होनी आरंभ फॉर वैलिड रीजन प्रथम सोमवार टा कौन गोटे होता मोर मन पड़ुनी ए सोमवार रे मु गली छाड़ापी सका 6टार आउ कमिंग मंडे देखा जाऊ से पैटर्न न हो हेनी कहीं हम शुक्रवार दिन देखा बाय बाय
Thank you, sir.
Thank you, sir.